Okay, this is 2.5. We're going to be talking about equations of lines and linear models. Alright, a lot of the times when we're trying to predict the future by using some math equation, the most sought after model is usually linear. It's just simple to use. And in the short term, it tends to be accurate. So most of our mathematical models that are helpful for predicting future events tend to be linear. So linear equations out of this form, y equals mx plus b, this is called slope-intercept form. The value m is our slope, the value b is our y-intercept. I guess we could also use function notation f of x and replace our y with f of x, same thing. Alright, the graph of a linear model is a line, and it can be described by two pieces of information. What we said is the slope. The slope is this letter m, and our y-intercept. So let's just start calling slope m. And the y-intercept. The y-intercept is a point on the y-axis, so its x-coordinate is 0. So that's what this b is talking about over here. It's the point 0, b. Okay, so how do I find the slope between 2 points? Also, by the way, the slope sometimes is called the average rate of change. So if you see the words average rate of change, just think slope. It's synonymous. If you're given two ordered pairs, so if you're given 2 points, x1, y1, x2, y2, then you can use this. You can find the slope by using the following formulas here. So our slope m is going to be the difference in the y's, so y2 minus y1, divided by the difference in the x's, x2 minus x1. It's also called rise over run. So the difference in y's over the difference in x's. You can also say y1 minus y2 over x1 minus x2. It doesn't matter. Okay, so horizontal and vertical lines. A horizontal line has slope 0. Its slope is 0. So then it's of the form y equals 0x plus b. Well, 0x is gone, so y equals b. That's the equation of a horizontal line. Y equals some value. The value is where the horizontal line hits the y-axis. Vertical lines. For vertical lines, sometimes we say that the slope is undefined or infinite. And vertical lines are not functions, so we cannot use f of x notation for them. We cannot use function notation. And the equation of a vertical line is just x equals the value where my vertical line hits the x-axis. X equals 3, x equals a in this case. Okay, first little exercise of this section. Let's find the slope between the points 2, 3 and -5, 4. So let's find that slope, and then let's interpret this slope. Take a second, try to find the slope, pause the video, and then let's check our answers. Alright, so I am going to say the following. So my slope is going to be the difference in the y's, and I could say either 4 minus 3, but then I have to say -5 over -2, or I could say 3 minus 4 and then divided by 2 minus -5. It doesn't matter which one I use, just be careful with the signs. So right now I'm going to say the following: 4 minus 3 over -5 minus 2. Alright, well that's 1, and this is -7. -1/7. What does this mean? What does this mean? Well, you can interpret it in a few forms here. I guess we could also apply the negative to the numerator if we wanted to. It's the same fraction. What does this slope mean? So let's see. Let me try to sketch what's going on here. So I am going to draw a tiny little Cartesian plane. Let me think about the point 2, 3. So 1, 2, 1, 2, 3, 4. So 2,3 I'll say is somewhere right around there. That's my point 2,3. The point negative 5,4. Well, 1, 2, 3, 4, 5, negative 5,4 is up here. And what the slope is saying is that, so let me kind of sketch it a little bit nicer. Sorry, this is a very ugly little graph. That's kind of the idea there. It's negative slope. It's kind of small slope. So the fact that if you ignore the sign, if the number is close to 0, your line is almost horizontal. And you can sort of see that this line is almost horizontal. Why? Because 1/7 is very close to 0. What this is saying is that I'm supposed to go down 1 and to the right 7, or up 1. From any given point I can go up 1 and to the left 7, and that gives me the next point. So for instance, if I start at this point 2,3, I go down 1 and to the right 7, at what point do I end up in? So sorry, I'm starting at the point negative 5,4. If I am at the point negative 5,4, if I go down 1 and 7 to the right, you should agree that we end up at the point 2,3. That's what the slope is telling me. The steepness of the line. Okay, so hopefully we agree with this slope. So what are some applications of slope? Well, there's many applications of slope. There's many applications out there, but one that I can think of right now is determining if lines are perpendicular or parallel. Two lines are going to be parallel if they have identical slope, if the slope is exactly the same. Two lines are going to be perpendicular if their slopes are negative reciprocals of each other. So two lines are perpendicular if they have negative reciprocal slope. So keep that in mind. We're going to use this in a second here. All right, let's think about the next example. So in 2008, farmers received an average price of $157 per ton of baled hay. In 2000, they received $84.60 per ton of baled hay. We want to find the average rate of change in price per ton of baled hay from 2000 to 2008. So take a second, try to pause the video and see if you can find this average rate of change. Remember, average rate of change just means slope. Okay, so let's find this average rate of change. Note that they give us this little hint here. We often use 0 as a base year. So right now what I'm going to do is I am going to consider the year 2000 as the base year. Which means that pretty much we're going to say 2000 is kind of like 0 for us. Yeah? And this is kind of a weird situation here, but you know what I mean. I don't like this equal sign here. Let's just say it's equivalent. 2000 right now is equivalent to saying 0. Okay, so then I have 2 points. I have the point 0, 8460. And then I have the other year, 2008, and the price was 157. Well, instead of writing 2008, I'm just going to say 157. Yeah? And now it comes down to figuring out the slope between these 2 points. So I'm going to say the following. I'm going to say average rate of change is going to be equal to, well, I'll say this. I'm going to say 84.6 minus 157. So that's the difference in my y's. This y minus that y divided by this x minus that x. So divided by 0 minus 8. All right, this is, I know that my numerator is going to be negative, my denominator is also negative, so the whole fraction should end up being positive, because if we divide a negative by a negative, the result is positive. And let me punch this into my calculator and round to the nearest penny, or the nearest cent, so hundreds, and I end up with 905. This represents an amount of money. Now let's think about what this means. What I mean, how do we interpret this? What can you conclude? I mean, what is this $9.05 telling me? I guess if we really needed to summarize this, what we can say is the following: that the price per ton of bale hay So the price per ton of bale hay increased by about, or actually just by 905 So the caffeine shakes, 905 per year from 2000 to 2008. I guess that's what the 905 is telling me, that the price per ton of bale hay has been increasing by 905 per year from the year 2000 to 2008. That's my average rate of change. Okay, let's move on. All right, so in general, this equation, we said, gives us the slope and the y-intercept, and it makes things a little bit easier because then it's easy to graph. If I know the y-intercept and I know the slope, it's easy to come up with a sketch of the line. All right, so let's see. Let's think about these next examples. For these examples, we're supposed to find the slope, the y-intercept, and then we're supposed to graph each little equation. So take a second, try to do them on your own, and then just let's compare answers. All right, so for the first one, this one's a little bit more straightforward. The slope is just 2/3. The y-intercept is the point 0,4. And let me make a little sketch of this then. All right, so let's see. Let me first sketch out the y-intercept. So that's 0,4. All right. Now I want to generate another point on this line. Any other point will do. What I can do is I can use the slope. So what the slope is telling me is that from this point right here, from the y-intercept, I could either go up 2 and to the right 3, or I could also go down 2 and to the left 3. It's the same thing. Yeah, so I could do that. So I could go down 2 to the left 3, or I could go up 2 and to the right 3. Yeah, and I'll get a different point, but it'll be a point on the line. Another way that I could go about this is I could find the X-intercept. I could find where it hits the x-axis. So in order to find an X-intercept, I can set my y equal to 0, and so for x. And if I do that, I end up finding my x-intercept to be -6. -6. Verify that. Do that on your own and see if you agree with me. And if you think about it, so here, think about, I'm at this point. If I go down 1, 2, and then to the left 3, 1, 2, 3, and then I go down another 2, 1, 2, and then to the left 3, 1, 2, 3, I end up at this point, -6,0. So that's the x-intercept right there. And well, my little line just looks like that. It's my little line segment. And that's what's going on there. All right, let's think about the next one. So for the next one, I gotta do a little bit of work to discover the slope and the y-intercept. I first gotta put my equation, which right now is in what's called standard form. I gotta put it in this other form, in slope-intercept form, which means let's solve for y. Alright, so let me solve for y. If I solve this thing for y, I end up with this. 2y is equal to -5x plus 10. And then let me divide everything by 2. So that says -5/2 x plus 5. Alright, so from here I can conclude that my slope is -5/2. And my y-intercept is the point 0,5. And well, let me just kind of make a little sketch here of the graph for this. So 0,5 is one of the points on my line. That's right there. That's 0,5. Now I'm going to find the x-intercept again. Or you could just say, oh, look, according to my slope, to generate another point, what I can do is either go down 5, 1, 2, 3, 4, 5, and to the right 2, 1, 2. Or I could go up 5, 1, 2, 3, 4, 5, and to the left 2, 1, 2. Either way, it gives me a point on the line. Right now what I'm going to do is I'm going to go down 5 and to the right 2. And if you think about that, that just puts me right on the x-axis. That actually gives me my x-intercept, which should be 2,0. Alright, and wow, I'm really bad at drawing straight lines, but you get the idea. Okay, good. I hope that we agree on the slopes. And also think about the x-intercept. Even though the slope is very nice, it tells you a lot of information about the line, you can always corroborate it further by knowing the x-intercept. All right, point-slope form. There's this other form of a line called point-slope form. Why is it called point-slope? Because what you're given is a point. You're given a point. The point is x1, y1, and you're given the slope. If you have those two pieces of information, then you can put them into this little equation right here. Okay, so let's see. Let's get into the next examples. So the next example is, let's find an equation of a line through the point 4,1 with slope -4. Take a second, pause the video, just do it on your own, and then let's compare answers. Alright, so this little exercise is simple because they already gave me the slope. I don't even have to work for the slope. Sometimes you have to come up with the slope yourself. But right now I'm just going to use my point slope formula and say, okay, so my equation is, oops, let me change it back to red. So y minus 1, so y minus my y coordinate is equal to negative 4 times x minus my x coordinate, x minus 4. That is it. That's the equation of the line I'm looking for. That's it. I'm done. The only thing though is that this point slope form is not, maybe, I don't know. Let's take it one step further and actually put this equation in slope-intercept form. So y equals mx plus b. So I'm going to say y minus 1 is equal to negative 4x plus 16. And then I'll add a 1. So y equals negative 4x plus 17. That's it. I guess either of these forms is acceptable. Just over here now I know the y-intercept. The y-intercept is 0, 17. What's going on here? Okay, there we go. Alright, next example. Find the equation of a line through 3, 1 and negative 2, 4. So try to find the equation of a line that passes through the point 3, 1 and negative 2, 4. Take a few minutes, take 5 minutes, pause the video, do it on your own. Then let's compare answers. Okay, the first thing I gotta do is find the slope. So let me work on the slope here. So I'm gonna say 4 minus 1 divided by negative 2 minus 3. So that's 3 over negative 5. That's my slope. Okay, now what I'm going to do is I am going to use the point slope equation, because I have, right now, I have a slope and I actually have 2 points. Does it matter which point I use right now? No, it doesn't matter. I'm just going to choose whichever point I think makes my arithmetic a little bit easier. I don't know which that one is. I don't know. I'm just going to use the point 3, 1. Although if you use the point negative 2, 4, we should end up with the same equation. Alright, so I have my slope. Oops. I have my slope. Now let me do this. Y minus 1 is equal to negative 3/5, because that's my slope, times x minus 3. I am using this point right here, so that's why I put a 1 there, and that's why there's this 3 there. Alright, so that's it. That is the equation of the line through these 2 points. The only thing is I'm gonna put this equation in slope-intercept form. So y equals mx plus b. Okay, and then the last thing I'm gonna do is add a 1 to both sides. And collect like terms. So this 1 has to add with this 9/5, not with the x's, because this doesn't have x. So plus 1 and the 9/5 are what are going to add. So I need a common denominator. I need to express 1 as some fraction with a denominator of 5. Well, then that's 5/5. So 9/5 plus 5/5 should be 14/5. That's it. That's the equation that I'm looking for. Hope we agree. All right, next example. Find the equation of the line that's perpendicular to this one, to this line, and goes through the point 2, 4. Remember that perpendicular lines are supposed to have negative reciprocals. Negative reciprocal slopes. So perpendicular lines have slopes that are negative reciprocals of each other. So pause the video, see if you can find the equation that we're after. Alright, so the first thing I gotta do here is find the equation of, find the slope of the line that was given to me. So I have 3x minus 4y equals 5. I want to identify the slope of this line. So I'm going to have to solve for y. So negative 4y is equal to negative 3x plus 5. Divide everything by negative 4. So then that says that this becomes 3/4 x minus 5/4. Okay, so all I've done is solve our original equation for y. The reason why I did that is because then that allows me to find the slope and I guess also the y-intercept. But right now what I need is the slope. Why do I need this slope? Because the line that I'm after, right now my goal is to end up with some equation that looks like this. Yeah, and this equation over here, this line is supposed to be perpendicular to this one. So then this slope right here should be the negative reciprocal of the slope of this one. So what I'm going to say is, so the slope of the perpendicular line is negative 4/3. All right, so then I have negative so what I can do now is actually I can just use the point slope form. I can just use point slope form and come up with the equation that I want. So I'm going to say the following. Look, our perpendicular line is supposed to pass through the point 2, 4, and it has slope, well, negative 4/3. So I have pretty much everything I need to come up with this equation. So it should be something like this. Y minus 4 is equal to negative 4/3 times x minus 2. That is it. That's the equation that I'm after. But I'm going to put it in slope-intercept form. Okay, so let me add 4 to both sides. 4 is the same thing as 12/3. So 12/3 plus 8/3 is 20/3. All right, so that's the equation that I want. Okay, so hopefully we agree on that answer. Last example. We want to find the equation of the perpendicular bisector through 2, 3 and 4, -1. So what is this perpendicular bisector? Well, it's a little line segment. So think first about the line that goes through the point 2, 3 and 4, -1. There's a little line that goes through those 2 points. And then there's another little line that intersects this line right at the middle of this line. That's why they give us this hint to use the midpoint. So take a second, see if you can figure it out on your own, and then let's check our answers. Okay, I'm going to try to set this problem up. Let me first kind of sketch what's going on here, so we get an idea. Alright, so I think I'm dealing with something. So I'm just going to literally plot these points 2, 3 and 4, -1. 1, 2, 3. So that's one of my points. That's 4, -1. And I guess I'm thinking about the little line that joins them right there. All right. So that's what I have right now. I have the point 2, 3 and 4, -1. Now, the perpendicular bisector. So the perpendicular bisector is a line that's perpendicular to this little one, to this little line segment, but also happens to start right in the midpoint of this line segment. So I am interested in the midpoint of this line segment. So let me find the midpoint. So there's a formula for the midpoint. Let me remind you. It goes something like this. x1 plus x2 over 2, comma, y1 plus y2 over 2. And right now what I want to do is I want to find the midpoint between 2, 3, and 4, -1. Alright, so let me think about the midpoint then. So it's going to be the sum of the x's divided by 2. So 2 plus 4 divided by 2, comma, the sum of the y's, 3 minus 1 over 2. Alright, well, that is just going to be 3, and that's going to be 1, because it's 6 over 2 and 2 over 2. So 3, 1. So 3, 1, that is my midpoint. Alright, and so then the perpendicular bisector is some line that starts right there at the midpoint. This is the perpendicular bisector. I'm just going to call it bisector. It's perpendicular. Okay, so now what I want, I guess what the question is asking us is to come up with an equation. The equation for the perpendicular bisector. Yeah? So in order to find the equation of the perpendicular bisector, I guess what we need is its slope and a point that happens to pass through the bisector. Well, we already have a point. The point 3, 1 happens to be on the perpendicular bisector. So that's good, we have a point. We just need to find the slope of this line. And how do I find the slope of this line? Well, since this line and this other one are supposed to be perpendicular, it definitely probably will help for me to find the slope between 2, 3, and 4, -1, and then use the negative reciprocal of that. So let me do that. Let's find the slope between 2, 3, and 4, -1. Alright, so I'm going to say that that slope is -1 minus 3 over 4 minus 2. And if you simplify this, this just ends up being -2. Okay, so then that's, right now think about what's going on. Right now that's the slope of the original line segment. So then what should be the slope of the perpendicular bisector? The slope of the perpendicular bisector should be the reciprocal, the negative reciprocal of this. So that should be 1/2. Okay, so now I have a point on the perpendicular bisector. The point is 3, 1, and I have the slope. So now I can actually come up with the equation of the line. So I'm going to use my point slope formula, and I'm going to say y minus 1 equals 1/2 times x minus 3. Right now I'm using the point on the perpendicular bisector and the slope of the perpendicular bisector. Alright, and so then this tells me that I end up with y equals 1/2 x minus 1/2. There's some intermediary steps right here, but do it and you should end up with the same equation. So that is the equation that I'm after. That's the equation of the perpendicular bisector right there. Okay, so that is it for this section. Thank you, and I'll see you in the next video.